Welcome, future secondary educators. Let's take a look at logarithms. And when we take a look at logarithms, we want to set up the basics to make sure that we understand where they come from, how they work, why they work, so we can explain them to young people. So the way this is normally set up is that you have some function y equals a to the x. And we have established in our previous work that that function is defined for all real numbers. No matter what the real number input is, it has an output. We can find that output using the rules that we've established. And so this function is, we can prove increasing, it's one-to-one, it's monotonically increasing on its domain. Its range is from 0 to infinity, 0 excluded. And so we can find the inverse of that monotonic function. That's the great thing about monotonic functions. So this function is the one that we call the log of x base a. Because a to the x has an inverse, we can find it, we can give it a name. And so this is what sets up for us when we write the log base alpha of beta equals gamma. What we mean is alpha to the gamma is beta. Now, that's how your textbook writes it, but really, we take a log for a base b, we take a log of a number n, and a log is an exponent. Logarithms are exponents. And that is equivalent to base to the exponent is the number. It's the Ben rule, named after the very famous mathematician Ben. With this being the case, can you justify that the log base alpha of alpha is 1? Can you justify that the log base alpha of 1 is 0? Can you do that? And then can you justify that the log base alpha of r times s is the log base alpha of r plus the log base alpha of s? Pause to make sure you can do that. Okay, we know that this statement would be equivalent to alpha to the 1 is alpha, and that's fine. And we know that this statement would be equivalent to alpha to the 0 is 1, and both of those are true, so both of these are true. This is a slightly more nuanced argument. So here's the way we do this. We start with the right side. And we say that this is equal to x plus y. Well, what does this mean? So this means that alpha to the x is r and alpha to the y is s, right? Which means that r times s is alpha to the x times alpha to the y, right? Which means, converting back, x plus y is the exponent that we put on alpha to get rs, and that means that this quantity and this quantity are the same, check. And you can similarly justify that the log base alpha of r over s is the log of r minus the log of s, both base alpha. You can justify that the log of r to the p is p times the log of r, regardless of the base. You can justify those. You can also justify that the log base beta of r is the log base alpha of r over the log base alpha of beta. You can justify that. I'll do that. It's not terribly difficult. We let y be the log base beta of r, that's this thing, and we let z be the log base alpha of beta, that's this thing. Well, what does that mean? Well, this means that beta to the y is r, and this means that alpha to the z is beta. Well, wait a minute. So that means that beta to the y is alpha to the z to the y, right? Alpha to the z is beta, so alpha to the z to the y is r. And this implies that the log base alpha of r is z times y. Well, this is the log of r base alpha, right? So this means that the log of alpha, log base alpha of r is z times y. And that very quickly gets us to here with a little bit of algebra, and we're done. Everything here is a property that you, a future teacher, can prove with teenagers. You should be well conversant in these ideas so that when teenagers ask you, how come this works, you can do more than say, hey, here are 3 examples on our calculator. 3 examples on our calculator gives us good intuition so that we believe that the thing is true, but it's not a proof. And there's nothing here that's beyond their level of rigor. They can figure this out with your help. And that's what I'll hope you'll do someday. Excellent. That's all for this lesson. It's a reading intensive lesson, not a video intensive lesson. I will see you when we gather.